What is up, Flutter devs? In today's widget workshop, we'll be building a flipping switch. Now, it's a switch like any other. It either has value A or value B, but when you change it from one value to the other, it does a 3D flip from one side to the other. And in this workshop, we'll be using this switch like a tab system that switches between two different kinds of content. Now, as always, if you enjoy what I'm doing here, if you like the channel and the video, do me a favor and subscribe to the channel and give the video a thumbs up. Also, share the message of Flutter with your colleagues and your friends. With that said, let's jump into the workshop. Let's create a flipping switch. And that flipping switch is going to go where this black rectangle is right up here. It's going to flip from one side to the other, and it's going to toggle the content that we have here in our app. Let's get started by declaring a stateful widget. We will call it flipping switch. And there are some details right off the bat that we know we're going to want. We're going to want a color, which represents kind of the accent color or the primary color of this widget. We're going to want a background color. We're going to want a left label, and we are going to want a right label. We'll generate a constructor with those properties. And now let's replace the black rectangle with a flipping switch. For our color, we're going to go with a yellow because I am me and this is a widget workshop. For the background, we're going to match the same background color that the rest of the UI has, which is this dark gray right here. The left label is going to be for free content and the right label is going to be for premium content. With that said, what do we actually want this thing to look like? Let's give it a set width of 250 and a height of 64. You could make this configurable in your implementation if you'd like, but I'll go with a set size. And then let's give it a box decoration here. The background color is going to be whatever our given background is. We're going to go with a border radius, which means rounded corners, of 32 pixels. That's because our height is 64 and our border radius is 32. We're going to have a pill-shaped switch. And we're going to give it a border on all sides with a width of 5 pixels, and we're going to use the accent or primary color for that. Let's see what that looks like. All right, so now we're getting ourselves off to a bit of a start here. That's our pill shape. Now, within that pill, we want a left label and we want a right label. So in the child property of our container, we can introduce a row. And we can give that row essentially two children. We'll make them both expanded so they both take up 50% of the available space. And within that space, we're going to center some text. Let's see, I'm getting all my alignments off here. Now, this is the left label. So we want to pass in the left label, and we're going to give it a text style. The color is going to be, once again, the primary color for our widget. The font size will be 24, and the font weight will be bold. Now we can just take this exact subtree, and we can replicate it, and then simply change left label to right label, and let's see what we got. The text looks all right, but I think the text is too large for the available space. So let's drop this font size down to 20. I think that's more reasonable. And with that, we have a basis for our switch. We essentially have the inactive pieces of the switch, and then we need the part that actually flips back and forth as we toggle, and so we'll work towards that in the following steps. To take us a step closer to getting the actual flip effect for our tabs, let's refactor a little bit. This whole creation here of the kind of background of our tabs, let's extract that. Let's go to refactor, extract, method, and let's call it build tabs background. And then with this method here, let's wrap it with a stack. And then let's build the flipping switch on top of the background that we've already created. So we need to implement a method called build flipping switch. We're going to explicitly position our flipping switch within the stack. So for now, we're going to say top, bottom are 0, right is 0. With top and bottom being 0, it forces our child widget to be exactly as tall as the stack. By setting the right value to 0, it pushes it, I guess in your case, all the way to the right of the stack. We'll have a child container. The width is going to be exactly one half the width of our overall stack. The height, we don't actually have to set it. The height would be forced upon us by the top and bottom, but just to be completely explicit, we'll go ahead and set the height anyway. And then we'll create a box decoration. This time we're only going to have 2 border radii. We're going to have the top right, which is going to be radius.circular, still 32. So the same radius as before, but we're just going to do the right side, which is because we're only covering half of the pill. And then we'll center our content again. It's going to be text. For now, we're going to replicate the right label, and you'll see why in a moment when you see what this does. And we will use the background color for the text color. We've essentially replicated the same kind of text display that we had before, except now the color of the text is the color of the background, and the color of the background is the primary accent color. Let's save and see what this looks like. So you see now we have this kind of active tab here, and this thing is sitting on top of the background. See, if we come up here to the right side and we offset it by 20, notice that it pushes it away. So this is a different thing entirely. This yellow half pill is its own thing sitting on top of the background that we created before. And in the next step, we'll begin manipulating that half pill to deal with rotating and flipping. Let's start playing around with a little bit of rotation. In our build flipping switch method, let's take in an angle. And we'll pass that angle in up here. For now, let's say, I don't know, 1/8 pi. To get a rotation effect, we want to take this container of ours and we want to surround it with a transform. That transform will start with an identity matrix, and then we will introduce a perspective matrix, which always looks very, very similar. This is a perspective matrix. The first value here is always 3. The second is always 2. The third value you can play around with a little bit, but it should always be somewhere close to 1/1000th, or you're going to get very skewed results. But with that perspective matrix, we then want to rotate along the y-axis or about the y-axis, and we'll pass in the angle. Let's save that. You see the little bit of rotation that we have here? Let's come up here and let's go 2/8. See how it's rotating out like that? Now, one issue that we do have is that notice that from a perspective standpoint, we're getting perspective down here at the bottom, but we're not getting any perspective distortion up here at the top. And that's an issue with the alignment of the matrix, of the transform. So we will set our alignment to a fractional offset of 0 and 1. Actually, that may have been too far. Well, that might be right. I guess it depends what angle you want here. So with this being near the top of the screen, we actually kind of we expect that the distortion should be at the top and not at the bottom. That it should kind of flip up and over, up and over. So by setting the alignment vertically up like this, we get the distortion along the top. But you can play with the alignment all you want, and you can get whatever distortion effect that you prefer. Now we're going to run into some issues pretty quickly with these angles. The first half angles look all right. We can go all the way up to 1/2. Now it disappears, and that's because it has no thickness and it's exactly kind of perpendicular to the background. But the problem begins when we go beyond the halfway point. You see, we've inverted it, and we don't want it to be inverted. We actually want it to be a regular display of the other tab. And so we need to take this into account. What we're going to do is determine whether we are showing the right tab or the left tab. We're going to represent that as a Boolean called isLeft. So if the angle is greater than pi/2, we need to be showing the left tab, not the right tab. And because we don't want it to be inverted, if we're showing the left tab, so we need to create a transform angle. We need to take the angle that's coming in and we need to alter it for our purposes. If we're showing the left tab, we actually want angle minus pi. If we're showing the right tab, well, we already know that the angle works. If we're showing the right tab, the angle is fine. But once we get beyond that halfway point and we're on the left side, we want our angle to be equal to angle minus pi. But this will now introduce a new set of challenges. So let me show you what happens here. Let's use the transform angle. Now let's go back to an angle that already worked. So we're still good on the first half. So 2/8, 3/8, 4/8, but now let's jump to 6/8. Notice that it's still showing on the right. 1, it's still showing premium when it should be showing free. 2, it's showing on the right. And 3, it's actually, instead of rotating forward, it's rotating backwards. These are all little issues that we're going to need to deal with. So let's just start solving a few of these. So let's start with this border radius. We only want a pill shape on the right if we're showing the tab on the right. Otherwise, we want the pill shape to be on the left. Therefore, if we are on the left, what we really want is a radius of 0. Now let's copy these and let's reverse them. Top left, bottom left, and now here, if we're on the left, then we do want the circular radius over there. And also our alignment. Our alignment is different depending on whether we're on the left or on the right. If we're on the left, we want a fractional offset of 1.0 and 1.0. So now we're seeing we are correctly seeing the perspective of a left side tab, but it's aligned to the wrong side and it's showing the wrong text. The text is easy enough for us to fix. Right here where we assign the label, once again, we'll say if left, then we show the left label, otherwise the right label. Okay, now we've solved the label problem. And then up here where we position it, is left. If we're on the left, we don't want to assign anything to the right. But if we're on the left, we do want to align to the left. Otherwise, we don't want to align to the left at all. Save that. And now we are where we expected to be. So now let's run through a number of these individual angles and prove to ourselves that we're okay. 0, 1/8, 2/8, 3, 4, 5, 6, 7, 8. Now we've done spot checks all the way through the rotation. Now we have the ability to actually flip this switch, though we're still controlling it manually. So in the following steps, we'll get this thing animated for us. It's time to start animating this switch. We'll start, as we always do, by bringing in a ticker provider state mixin. We will declare an animation controller. We'll call it flip controller. In init state, we will initialize the flip controller. We'll pass in ourselves as the vsync. For the duration, we're going to go with 500 milliseconds. Then in a dispose method, we will first call the super method, and then we will dispose of our flip controller. We'd like the ability to jump immediately to a given mode or position. And so if we want to jump immediately to the left being enabled, we'll put our animation controller at 1, otherwise 0. So 0% is the right side, 100% is the left side. When we begin our controller, it's going to be at 0, but we actually want to immediately jump. We want to activate the left side because when the UI shows up for the first time, we want this left side to be active, not the right side. Now, if you had implemented all of this in reverse, if you had made the left side 0 and the right side 1, then this would be inverted and you wouldn't actually have to jump anywhere. But because we started with the right side, we want to force it immediately to the left side. Let's also define a method called flip switch. If the flip controller is completed, then flip controller reverse, else flip controller forward. Then we'll come down here where we have our stack. The background never needs to change no matter what happens to the flipping switch. So we will surround our flipping switch part with an animated builder. We need to determine what the angle is. It will be pi times flip controller dot value. Do a hot restart to correctly initialize the widget. And of course, we need some way to trigger this animation, right? So we'll come down here to where we where we build our tab's background. And whenever we tap, like if we tap on this premium background right here, we want to flip. And then if we tap on the free background, we want to flip back. Now, flipping is the same operation no matter which direction you go. And therefore, we can actually just surround the entire background container with a gesture detector. And regardless of what we tap on, if we tap on either side, we're just going to flip the switch. Let's save that. How you like that? It's pretty sexy. But it could be sexier because it could have a little bit more dynamism in the animation curve. We could do a bit more of a kind of pressed spring effect, which we're going to do in just a few moments. And of course, we also need this switch to actually affect our content. So we need some kind of callback there. But we'll do those in upcoming steps. Let's get our flipping switch to actually change our content when we flip the switch. After all, that's the entire point of its existence. Let's take in a void callback called onChange. And actually, I take that back. It should not be a void callback. We actually want to pass the current value. So it's going to be a function that takes a Boolean which represents is left active. And then in flip switch, we're going to say widget onChange, and we're going to invoke it, in this case with false. So if we have completed, it means we're already, or from your perspective, we're already on the left. Sorry, your perspective, we're already on the left. If we're already on the left, then the left is already active. And if we're going to flip it again, it means we're going from the left to the right, which means left is no longer active. For the same reason, down here, the left is active. Right is active, left is active, right is active, left is active. Now we've implemented the callback, but we have to still actually respond to it. Up here, we will define onChange. We will take Boolean is left active. And I already have this tab controller provided. This is stuff I've already implemented. I'll take the tab controller. I will set its index equal to either 0 or 1. Let's save that. We'll do a hot restart just to be safe. And now it actually does its job. Over here, we have some premium content, some extended widget workshops available exclusively at school.superdeclarative.com. You should go check that out and purchase those premium resources. But for those of you that don't want to pay anything, you can just watch all this free stuff, including what you're watching right now. But anyways, I digress. The flipping switch now flips our content, but we still don't have a particularly compelling animation. We can do better than this. So let's see what we can do with a final animation polish. The first thing we're going to have to do is actually switch out this mixin. This is a single ticker provider state mixin, which means that you can animate up to one thing with this state object. But to get a slightly more nuanced animation, we actually need two animation controllers, which means we don't want a single ticker provider. We need a ticker provider state mixin, which allows us to create multiple animations and have multiple tickers. We want to add the concept of a tilt controller. And why is that? Instead of just animating the flipping switch, we're going to make the entire tab kind of tilt down when you tap on it. When we tap on free, it's going to tilt down a little bit. Okay. So we're going to define a max tilt angle. It's going to be pi over 6. And we're going to define a tilt animation. And well, I'm misspelling tilt all over the place. Not title, tilt. Here in init state, we are going to instantiate our tilt controller. Once again, we're the vsync. The duration here is going to be 200 milliseconds. And the reverse duration is going to be a lot more at 1500. And we'll add a status listener. Now this probably looks pretty weird. So let me explain what's going on here. We're actually going to combine kind of two different effects together. When we press down, we're going to animate forward. That animation is going to run very quickly, 200 milliseconds, and it's going to use a typical ease out curve. But then that's going to push down or back, and then we're going to reverse the animation. But when we reverse the animation, it's going to take much longer, and that's because we're actually going to give it an elastic animation in the reverse. We're going to press down and then elastic a little bit back. So you'll see what that effect turns into, but that's why you're seeing these differences here, and that's why you're seeing us automatically reverse when we complete the animation. So that's the tilt controller, but we're also going to have a tilt animation. Did I not name that correctly? Geez, I cannot get that word correct. Tilt animation is going to be a curved animation. Its parent is going to be the tilt controller. So that's what it's going to apply itself to. The curve going forward is going to be an ease out curve. But here's where some of the magic happens. The reverse curve is going to be elastic out, and we're going to flip it because it's in reverse. This elastic part is why this number is so large. So it can kind of spring back and forth. In dispose, we now need to get rid of both of these controllers. And then we need to do appropriate things here in flip switch. So let me add a direction multiplier up here. This represents the direction of the tilt animation, because based on whether we're applying it on the left side or the right side, the direction needs to be different. So here, in this case, if we're flipping from left to right, our direction multiplier is equal to -1, and we will tell our tilt controller to go forward. If we're flipping from right to left, our direction multiplier is going to equal 1, and our tilt controller, we will still tell it to go forward. Now, the reason that we're using a direction multiplier instead of just reversing the animation is because the way we've coordinated our animation is that we reverse it ourselves. We actually need both directions of the animation. So instead, we explicitly control the direction based on whether we're applying it to the left side or the right side. And then all of this comes to head when we actually apply the values down here. Let me correct some of this stuff going on. Now we're going to need to rearrange our tree a bit. Previously, we were only animating the flipping switch, but now we're animating the entire set of tabs. Therefore, at a top level, we actually want to return an animated builder. And its animation is going to be the tilt animation. There is still a part of this that never really changes. We can essentially take all this stuff down here that we already had, and we can install it as a child of the new animated builder, which gets passed in right here. This stack and everything within it gets passed right here. We can call this tabs, for example. But now we're going to introduce another transform. So we're going to return. So we already have one transform for the flipping switch. We're going to create another one. So we're actually transforming within a transform for the flipping switch. Once again, we want a perspective matrix. Now this time, I actually want to go 001 instead of 002 because I think it gives us a more appropriate distortion for this effect. We want to rotate once again about the y-axis. We're going to take the tilt animation. We're going to get its value. We're going to multiply, and that value is between 0 and 100%, right? So we're going to multiply that percentage by the max tilt angle, and then we're going to multiply by that direction multiplier. This is where that direction multiplier comes into play. Now this transform, its alignment, we're going to do fractional offset 0.5, 1.0. And this again is so that it looks like we're flipping. It looks like our perspective is down here and our flip is up and over. That's what this fractional offset is for. And then what are we transforming? Our tabs. The whole thing, the whole tabs. Now let's see if we happen to get that right. Let's do a hot restart to get all the initialization correct. Now let's give it a try. Do you see that little kind of almost like dimple effect? When I tap, it goes down and then it springs back. The part that goes down, that's the forward animation. All the rest of it is the reverse animation. Down and then spring back. Down and then spring back. Okay? Now I'm sure you could accomplish that with just one animation curve instead of two, but you would need a custom animation curve because the ones that are built in don't have this particular curve. So you'd need to go ahead and code up that curve that you want. But we now have a switch that actually changes content. The switch flips and it tilts. I think it's a pretty cool little effect. Didn't take a whole lot to get there, It's all in the widget tree, no custom painter, just a bunch of declarative UI and a bit of animation controllers, and there you go. So that is today's widget workshop. I hope you learned something, and I'll see you in the next one.